Hello, my name is Dhruv and I am today discussing competitive analysis between ESP32 and ESP8266. So first, we are starting with introduction to ESP32 and ESP8266. Importance in IoT applications. Both ESP32 and ESP8266 plays crucial role in Internet of Things, supporting smart home devices and industrial automation. The features of the microcontrollers helps the developer to implement creative solution and advanced technology in IoT technology. Now, architecture overview. ESP8266 contains single core 32-bit RISC architecture. This design makes it suitable for simple tasks in IoT application, which is handled on the basic level with moderate power consumption and cannot do more further application things. Now, ESP32 contains dual-core 32-bit RISC architecture and have advanced design allow it to perform multi-threaded operations and do more complex applications with advanced technology and do more multitasking processes. Now, processing power. The processing power of ESP8266 contains the 80 megahertz and this speed supports adequate performance for simple IoT application, but it is limited to multitasking capabilities in more resource intensive scenarios. ESP32 clock speed. The ESP32 significantly enhances processing power with the clock speed of 240 megahertz. The higher the clock speed enables the execution of more complex calculation and advanced searching content such as robotics and variables. Now we will see more, memory specification of ESP modules. As so far, memory plays the crucial role for the performance and capabilities uh, of the RAM in the microcontrollers to perform in the applications. The ESP8266 features 160 KB of RAM, which is sufficient for basic IoT application. This limitation may restrict complex algorithms or multiprocessing running simultaneously. ESP32 RAM specification. It contains 520 KB of RAM, which is more than the ESP8266 and do more multitasking with the advanced functionalities and complex application. Now understanding GPIO pins in ESP32 device. Number of GPIO pins in ESP8266. There are total 17 GPIO pins which provide connectivity for various sensor devices and components. Despite its lower pin count compared to ESP32, this pin can be used for digital input, output and PWM signals, making the ESP8266 suitable for simpler IoT application. Number of GPIO pins in ESP32. The ESP32 significantly enhances functionality with up to 34 GPIO pins. This extensive range facilitates complex interfacing options, allowing more devices to be connected and supporting advanced applications. So it can do more performance in advanced application and can do more abilities than ESP8266. Now, wireless capabilities. ESP8266. It supports Wi-Fi connectivity exclusively, functioning efficiently in IoT projects that require internet access. So it can connect only Wi-Fi for the application, but its limitation in wireless options restrict its versatility, mainly catering to simple applications such as home automation and remote monitoring. So as we seen before, and this part we can say that ESP32 ESP8266 is done for only basic level, and now we have more advanced technologies, so we have to move towards ESP32 devices. So it contains both Wi-Fi and Bluetooth functionalities, enhancing its appeal for complex IoT application. This integration allows for seamless communication across multiple devices, providing a competitive edge in versatile project environments. Now, we see the connectivity options. ESP8266 connectivity limitation. It primarily supports Wi-Fi connectivity, which constrains its application in environments requiring multiple connection types. The limitation can inhibit integration in complex network needing Bluetooth or Ethernet capability, making it less flexible for advanced IoT application. ESP32 versatile connectivity. ESP32 supports numerous connectivity such as Wi-Fi, Bluetooth, and Ethernet. This versatile allows developers to create more complex and interlinked IoT projects, significantly expanding its use case in modern application. Now, programming environment. As the ESP8266 can be programmed using various platforms such as Arduino IDE, which provides an easy-to-easy interface for beginners and experienced developers alike. Another popular option is Node MCU, a firmware based on the Lua scripting language designed for low-level programming and rapid prototyping. As nowadays we are not using the ESP8266 microcontroller, as it is a low level programming and cannot be done multitasking in it. ESP32 development tools. ESP32 boosts a more versatile programming environment, support notably the Arduino IDE, but include ESP tailored for advanced functionality. Additionally, MicroPython allows for programming in Python, making development access to a broader audience. Now, the use case for ESP8266. So, we are seeing the uses of ESP8266 and the more features of it. The ESP8266 excels in simple IoT such as home automation, basic sensor monitoring, and smart home devices. It is low cost and moderate, and power consumption makes it deal for application requiring Wi-Fi connectivity without complex processing needs. So now use case is for ESP32. The ESP32 caters to more complex application including robotics, wearables, and advanced IoT system. So ESP8266 cannot do more applications in advanced technologies and can't do multitasking. So nowadays ESP32 is more used in the colleges and companies for the advanced technology of it. It contains also dual core processing power and Bluetooth capabilities, such enable sophisticated tasks such as real-time data processing and multitasking operations. Now we will see the cost and the availability of both microcontrollers in the market. Cost comparison. The ESP8266 is generally cheaper, making it suitable for simple IoT projects. The ESP32, while slightly more expensive, offers advanced features that justify its cost for complex applications. Now, the availability of ESP8266 and ESP32. The ESP8266 is widely available across numerous online and physical retailers, ensuring easy access for developers. The ESP32 is increasingly becoming available with growing distribution channels reflecting its rising popularity. So, now I have discussed about the general fundamental differences and the capabilities of ESP32 and ESP8266 in our modern period. So, thank you.